I will now turn it over to Dr. Robert Wright, co-director of the Institute for Exposomic Research and the Ethel Weiss Chair of the Department of Environmental Medicine and Public Health at Mount Sinai. Dr. Wright?
Thank you, Terry. Thank you for that wonderful introduction, for leading us through today's program. So I thought we should first start with telling you a little bit about the Institute for Exposomic Research here at Mount Sinai. We are the sponsor of this conference, which is now being held annually. As Terry said, this is our fourth annual Clinical Climate Change Conference. Our institute studies how the environment affects health and does so with a new approach, an omics or comprehensive approach. We're leveraging and creating new technologies to translate environmental knowledge into strategies that prevent disease, improve diagnosis, and create tools that clinicians can use to better treat their patients. To meet our mission, we advocate, we educate, we provide care, and we innovate. Before we get to the discussion on climate change, I thought we could also review the importance of the exposome in shaping our development, health, and risk of disease. In the age of genomics, we sometimes lose sight of the importance of environment on our health, and that if we are truly to prevent and cure all diseases, we must invest in studying the exposome. Mount Sinai has done just that with our Institute for Exposomic Research. This slide shows why exposomics is so important. Many chronic diseases are on the rise, and genes alone cannot explain that phenomena, as genes cannot change in such short periods of time. We are already seeing increases in the prevalence of disease that are going on today. In fact, just recently, the CDC released data showing another increase in autism prevalence from 1 in 54 to 1 in 44. And other diseases such as Alzheimer's disease, cancers, and diabetes are all on the increase. Allergies are on the increase. This has to be due to changes in our environment, some of which are directly or indirectly due to climate change. In fact, environment plays a role in every disease. This slide shows the importance of environment and disease risk compared to genetics, but in truth, it's much more complex than that. In fact, it is our hope that in the future, we stop dividing causes into genetics and environment, and instead think about how our genes and how our environment interact, because that's really how disease occurs. Take asthma, for example. There are studies in twins that show that asthma is 82% genetic. If I were to tell you that, you would think that out of every 100 people with asthma, 82 of them got it because of their genes and 18 got it because of their environment. But that's not what it means, and that's also not how people get asthma. In fact, there is no gene or cluster of genes that by itself causes asthma. And also, we know that environmental factors play a role in every person with asthma, whether it's pollen, animal dander, air pollution, stress, and many others. So asthma is not a genetic disease, nor is it a purely environmental disease. It is how our genes and our environment interact, and that is how we should study it. So what is exposomics? I think we can all agree that biology is complex and life stage changes the way our bodies operate. Our environment is equally complex. These systems do not exist independently of one another, they interact, and that is really the definition of a gene-environment interaction. Exposomics allows us to effectively measure these complex systems and understand how they interact with our genome across time. So what are we working on at Mount Sinai? Well, we're collecting health data from baby teeth, hair, decades old, newborn blood spots to understand a person's past, even in their fetal environment. We're also using satellite imagery, partnering with NASA to drill down to understand air quality, climate change, and temperature variation from one neighborhood to another. We use wearable devices to capture an individual's unique exposures in real time and also link them to satellite models that I described previously. With these technologies, we can collect rich exposure data on the environment and on diverse parameters such as air pollution, weather, temperature, and even social stressors. Climate change interacts with virtually all aspects of the environment that impact health. This complexity means that to understand these effects, we must measure environment on a grand scale and repeatedly over time. Not all risk is equal. Age, poverty, where you live, and pre-existing conditions compound the impacts. Climate change will have many downstream or butterfly effects. These include increased incidence of vector-borne diseases due to expanded survival of vectors like mosquitoes and ticks as a result of altered temperature patterns. But they also include things like mental health. There are indirect effects of climate that are very varied. They can include changes in our use of pesticides and different types of behaviors, different distributions of allergens. Mold and its toxins are seen from flooding events. UV light exposure and vitamin D deficiency may be linked. Changes in nutrient content of food have been described. And there are microparticles of plastics in the products that we use that actually enter into our body, and they may have their own health effects. So climate change is very varied, and today's theme will illustrate one of the many effects of climate change, which is mental health outcomes. So today we're going to turn to how the current crisis is affecting the mental health of so many. And I look forward to learning from all our presenters.